The concept of the wavelength of white light is a bit nuanced because white light is not associated with a single wavelength. Instead, white light is a combination of different colors across the visible spectrum. The visible spectrum consists of various colors, each corresponding to a specific range of wavelengths. These colors include red, orange, yellow, green, blue, indigo, and violet. When all these colors are combined in the right proportions, they create the perception of white light. Unlike colors like red or blue, which are associated with specific wavelengths, white light is more of a perceptual experience. It occurs when our eyes detect a balanced mixture of different wavelengths. So, to answer the question, what is the wavelength of white light? It's essential to understand that white light is a blend of multiple wavelengths rather than a single, distinct wavelength. Unlike colors such as red, which has a specific wavelength around 700 nanometers, or blue with a wavelength around 450 nanometers, white light is more of a perceptual experience. It occurs when our eyes detect a balanced mixture of these various wavelengths. So, in essence, there is no specific wavelength for white light like there is for individual colors. White light is the result of combining multiple wavelengths, and its perception is based on the interaction of our eyes with this diverse range of colors. The lights never mix together to form a new light of different wavelength, instead our brain, according to which rod cell is simulated, makes a perception of white light. When we talk about the colors of light, what's happening is the stimulation of different types of cone cells in our eyes, specifically, the red, green, and blue cones. These cells are sensitive to different ranges of wavelengths. When light of various wavelengths enters our eyes and stimulates these cone cells, our brain processes this information and creates the perception of different colors. In the case of white light, it's the simultaneous stimulation of all three types of cone cells by a balanced mixture of various wavelengths across the spectrum that gives us the impression of white.